Hello everyone, I am Teacher Michelle and welcome to another episode of Unang Math. In this episode, we will be solving some questions or problems applying the basic proportionality theorems. Without further ado, let's start with this first question. If segment BC is parallel to segment ED, find the value of x plus y. So this is our figure. And according to this, segment BC is parallel to segment ED. So these two lines are parallel lines. Find the value of x plus y. X is the length of segment ED and y is the length of segment AB. We already studied the concept of similar figures, the concept of right triangle altitude theorem, and the concept of basic proportionality theorem. Okay, let's find out which of those concepts is or are applicable in this question. Okay, so you can see we have here two triangles. But these two triangles are not right triangles. So we cannot use the concept of right triangle altitude theorem. Okay, how about, are these two triangles similar figures? Okay, let's find out if these are similar figures. Okay, again, segment ED and segment BC are parallel lines. Okay, it means this angle and this angle are equal in measures. It's because these two angles are alternate interior angles. Same reason with this angle and this angle that are also equal in measures because these are alternate interior angles. We also have this angle that's equal to this angle because these angles are vertical angles. So from this, we already proved that these two triangles are similar figures. So it means the ratio of the length of the corresponding sides are equal or constant. So let's name this triangle AED. So this is triangle AED, and this is and this triangle corresponds to triangle ACB. So triangle ACB. We are looking for the length of this segment ED or DE. So this is our X, and segment ED or DE corresponds to segment CB, which is 6 centimeters. To find what would be the length of segment ED, we have to know the ratio of similarity. Since segment AE is given 4 centimeters, this corresponds to segment EC, which is 8 centimeters. We can now find the ratio of similarity. So this is 4 is to 8. If we will simplify, then now this is 1 is to 2. So ratio of similarity is 1 is to 2. So 1 is to 2 is equal to x is to 6. So if we will solve, so this is 2x is equal to 6. So it means x is equal to 3. So the length of segment ED is 3 centimeters. Okay, how about the length of segment AB? This is our y. So AB is y. Segment AB corresponds to segment AD, which is 6 centimeters. Okay, our ratio of similarity is 1 is to 2. So 1 is to 2, that's equal to 6 is to y. So this is 12. This is y. So it means y, or the length of segment AB, is 12 centimeters. So we found out the length of this segment in this segment using the concept of similar figures. But if you know the concept of proportionality theorem, then it would be easier to find the length of this segment and the length of this segment. Okay, we know that this segment corresponds to this segment. So we have here, this is y is to 6. This segment AC corresponds to this segment AE. So this is equal to 8 is to 4. And this segment, which is 6 centimeters, is equal to this. This segment corresponds to this segment ED, which is our X. So this is 6 is to X. Okay, if we will simplify, then this is 2 is to 1. So, if we will solve, so we have here 12 is equal to Y. So, Y is equal to 12. What about here? So, this is 6 is equal to 2X. So, it means X is equal to 3. So, it's a lot easier and faster to find the length or the measure of this segment and the measure of this segment if we know the proportionality theorem. So, in this question, the value of X plus Y, so we have 3 plus 12, then this is now equal to 15. Okay, now let's go to our second question. According to this problem, in triangle ABC, so this is triangle ABC, segment BC is parallel to DE. We will find the value of X plus Y. Segment BC is parallel to segment DE. Find the value of X plus Y. So, X is the length of segment AD, Y is the length of segment BC. Okay. These two triangles, we have here this smaller triangle and this bigger triangles. These are similar figures. It's because this angle is equal to this angle. These are corresponding angles. Also, this angle is equal to this angle. Same reason, corresponding angles, because BC and DE are parallel lines. So, if we're going to recall the concept of basic proportionality theorem, this segment corresponds to this segment. This corresponds to this segment. So, AD, which is X, is to 10. So this is equal to this segment 3 is to 6. So if you're going to simplify this is now 1 is to 2. So X is to 10 is equal to 1 is to 2. So it means this is 10, this is 2X. So X now is equal to 5. So the measure of segment AD is 5 centimeters. Okay, now, how about the measure of segment BC? Okay, take note, we cannot use the same ratio. Because if we are going to use the same ratio, it would be this length and this length that corresponds to each other. This one should be this one, or this segment should correspond to this segment. So, since we are going to find the measure of segment BC, okay, what ratio are we going to use now? So, it would be the ratio of this length and this length. This length should correspond to this length. So, this length would be equal to this length. So, in here, let's use this length because these are given. Both are given. So, AE is 3 centimeters is to 3 plus 6, it would be 9. So, we have 3 is to 9. This is now equal to 4 is to Y. So, simplify, this is 1 is to 3. So, 1 is to 3 is to 4 is to Y. Okay, that's why Y is equal to 12. So, Y is equal to 12 centimeters. Or segment BC is equal to 12 centimeters. So, what would be the value of X plus Y? So, we have here 5 plus 12. Then, this is now equal to 17. Okay, for the last and final question, let's also answer this one. In triangle ABC, or this triangle, if BC is parallel to DE, BC is parallel to DE, and AC is parallel to DF. And if segment AE is 12 centimeters, CE is 9 centimeters, and DE is 8 centimeters, we will find the length of segment BF. So what would be the length of this segment? So as you can see here, it's given that this is parallel to this segment or to this line. Since we have this line here that's parallel to this line, so we have this figure here, and we call this a parallelogram. So it means if this is 8 centimeters, then this is also 8 centimeters. If this is 9 centimeters, then it means this is also 9 centimeters. Okay, we have this triangle, this biggest triangle, and this smallest triangle. And these are all similar figures. So, if these are similar figures, then the ratio of the length of the corresponding sides are equal. So, how are we going then to find the ratio or the length of segment BF? Okay, again, ABC, a triangle ABC, okay, triangle ADE, and triangle DBF, or the smallest triangle, DBF. These are all similar figures. Okay, to find what would be the length of segment BF, so segment BF, so this is, let's say, Y. Okay, we're looking for this segment. Segment BF corresponds to segment DE, which is 8 centimeters. Okay, we have to find out the ratio of similarity in order to find what would be the measure of segment BF. So in here, since AE is given, or segment AE is given, which is 12 centimeters, okay, this corresponds to segment DF, which is 9 centimeters. So this is 9. So we have 12 is to 9. And if we will simplify 12 is to 9, then this is now 4 is to 3. So this ratio 4 is to 3 is equal to 8 is to y. So if we will solve, so this is 24 is equal to 4y. So it means y is equal to 6. So in here, segment BF is equal to 6 centimeters. So the length of segment BF is 6 centimeters.